let's take a look at your seminar on isosceles and equilateral triangles, MT5, LT6. As normal, do the first 5 questions and then come back and we'll continue on the seminar. What I want you to do today, if you haven't figured it out just by the name, I want you to solve problems involving isosceles triangles and equilateral triangles. First, we have some vocabulary concerned with an isosceles triangle. Remember, an isosceles triangle has 2 sides the same. We call those legs. The other side that's not the same is called the base. Well, as it turns out, that if you have an isosceles triangle, you also have 2 angles that are the same. They lie along the side of the base, so we call those base angles. No, just highlight them right here. Okay, and then the angle that is different is called your vertex angle. So you have base and legs. Now we have the isosceles triangle theorem, which just says what I just got done telling you, that if you have 2 sides the same, you know the base angles are congruent. And they're always across from your congruent side. So you have to look at what sides are congruent and then do it. And then we have the converse of that says if you have 2 angles of the same in a triangle, that means the sides opposite them are congruent. We can do a proof by an auxiliary line. Now, we used an auxiliary line when we proved the angles of a triangle add to 180, but that was usually in the parallel postulate. Here we're just going to draw in any line, and that's what we're going to do in this first example. So what I'm going to do here is I'm given a couple things. I'm given triangle LMP, so we have that. I'm also given LM is congruent to LP. I think I'm going to write that down in my proof right away. I'm not going to wait. LM is congruent to LP is given. When you're doing somebody else's proof, it's always kind of nice to write your given and right away. Then we're going to put N right in the middle of MP because we can draw that in however we want. That's your auxiliary line. It says draw an auxiliary line, reason, auxiliary line. Maybe you might want to say because it goes through 2 points, 2 points determine a line because my line is going to go through L and N. And so when I draw that in, you could say 2 points determine a line. Now we're going to say, why is MN congruent to PN? Notice I already got it marked. Well, I notice that's the same because it's the midpoint. So now we got MN is congruent to PN. LN is congruent to itself. So that is going to be reflexive. And we said LM, we'll put 3 tick marks on there, is congruent to LP, because I'm given that. And then why are these 2 triangles congruent? Well, notice you've got side, side, side. What's always the reason after the triangles are congruent? Well, that'll be CP, CTC. Corresponding parts are congruent, triangles are congruent. So we know angle M is congruent to angle P. Now, on the next problem, we want to find the length of each side and find the missing angles. Well, the first thing I'm going to do, if I'm going to do that, let's find the coordinates of all of our points. So notice A is up 1, 2, 3. So A is at 0 and 3. And then C is over 1, 2, 3, 4. To the left 4. And it's down 1, 2. B is symmetric to C. It's at 4, 2. notice then, so when I find my distance, A to B is going to equal A to C because they are symmetric. So let's just use our distance formula here. Remember, subtract your x's, so I'm going to say 4 minus 0 squared plus 2 minus 3 squared. Actually, it's negative 2. I'll put that negative 2 in there. Sorry about that. Just notice that now. So 4 minus 0, that's 4 squared. Negative 2 minus 3 is negative 3 squared. So I get the square root of 16 plus 9. And 16, 3 minus a negative 2. Well, negative 2 minus 3. Oh, holy buckets. Am I dumb? Let's back up here. Negative 2 minus 3, I'm sorry. That's negative 5, isn't it? Something wasn't checking there. Okay, so then I get plus 25. So I get the square root of 41 for each one of these. And then to find B to C, that one I don't have to use the distance formula because it's a horizontal line. I'm going from 4 to negative 4, so B to C is 8. So I've got an isosceles triangle. Since I have an isosceles triangle, I know my base angles, B and C, they're the same. So to find the measure of angle B, that'll be the same, whoops, brain is talking faster than I'm writing. The measure of angle B equals the measure of angle C. Well, what I'm going to do is I'm going to take 180, because degrees in a triangle. I'm going to subtract my vertex angle, which is 70. I'll divide that by 2 because I know they're the same. So when you do that, you get 110 divided by 2 gives us 55 degrees. And there is your answer. Now, we have a couple corollaries that go along with this. One of them, remember, a corollary follows directly from another theorem. If I have a triangle that's equilateral, I've got 3 equal sides, so I must have 3 equal angles. And if it's equilateral, I know each angle has to be 60 degrees because they're all equal. 180 divided by 3 is 60. So if I look at another example here, I've got a triangle, isosceles triangle. Since it's an isosceles triangle, I know the base angles are the same. Come on, I want to make this a little bit thinner because I blew it up. No, it is thinner. So I know angle K is 60 degrees. Well, if I got two 60-degree angles, I know angle J is 60 degrees. Yeah, so there's our work. So the measure of angle J is going to be 60 degrees.